First-order equations with one variable. The simplest type of equation is the first-order equation with one variable. As the name implies, such equations have a single variable, which is in the first power. The terms first order or first degree are used to describe equations or polynomials, as we will see in Chapter 11, where variables appear in the first power only. For example, 2x minus 4 is equal to 0 is a first-order equation with one degree, as there is a single variable, x, in the equation and this variable is in the first power, x1 equals x. On the other hand, equations such as 5x plus 2y equals 6, and x squared plus 3 is equal to 7 are not of the first order with one variable, as the first equation contains two variables, x and y, while the second equation is not of the first order as its variable, x, is in raised to the second power. It is a second-order equation. Example 1. Are the following equations first-order equations with one variable? If yes, write them in the regular form. A. 3 minus 2x equals 5x minus. B. 1x 3x plus 2x equals 11. C. Y minus 4x equals 3x minus 2 minus 7x. D. A. minus 3b equals A, plus 4b minus 1. Solution 1. From theory, it is a known fact that a first-order equation must contain a single variable in the first power. However, to know whether the given belong to this type, we must first complete some operations to turn them into the simplest form. Then, we must write it in the form e, x, equals 0. For a, we have the following shown on screen. It is obvious that this equation is a first-order type with one variable. For b, we have the following shown on screen. This is an equation with one variable, but it is not of the first order, as the highest power of the variable is 2. This is a second-order equation with one variable, otherwise known as a quadratic equation, briefly discussed in Tutorial 6.4. We will deal more extensively with such equations in the next tutorials of the current chapter. At first glance it seems to be a first-order equation with two variables, x and y. However, after doing the operations with like terms and the simplifications resulting from these operations, for c, we have the following shown on screen. This is a first-order equation with one variable, y. Again, it seems like a first-order equation with two variables, a and b. But we will see during the operations that this is not true. For d, we have the following as shown on screen. Hence, given that the only variable in this equation is b and it is in the first power, this is an example of first-order equations with one variable. Solving first-order equations with one variable. Solving first-order equations with one variable means isolating the variable and expressing it in terms of the other elements of the equation, numbers and non-variable letters. The letter that represents more frequently the variable in equations with one variable is x. Therefore, the general formula of the first-order equation with one variable, we have the following as shown on screen. Where a and b are numbers, a is a coefficient and b is a constant. Solving a first-order equation with one variable means calculating the value of its variable. In math language, this process is called finding the root of the equation. This has nothing to do with the concept of roots explained in the 7th chapter. The necessary thing to do when solving such equations is to isolate the variable. Thus, we have the following as shown on screen. Dividing both sides by a yields, we have the following as shown on screen. For example, the solution of the equation, we have the following shown on screen. Is 2 because we have the following shown on screen. Example 2. Solve the following first-order equations with one variable, a, 2 minus 5x equals 17. b, 3x minus 6 equals 4y minus 5 plus 3x. Solution 2. A. First, we arrange the equation to show it in the form a, x plus b equals 0. Thus we have the following as shown on screen. We have a equals minus 5 and b equals minus 15. Thus, we have the following as shown on screen. B. Again, first we arrange the equation to show it in the form a, x plus b equals 0. Thus we have the following as shown on screen. We have a equals minus 4 and b equals 5. Thus, we have the following as shown on screen. Transformations that can be made in first-order equations with one variable. When solving a first-order equation with one variable, the following transformations can take place. 1. If we add or subtract the same number, variable or term from both sides of an equation, we obtain an equivalent equation. For example, we have the following as shown on screen. Are all equivalent equations? 2. Multiplying or dividing both sides of an equation by the same non-zero number gives an equivalent equation. For example, we have the following as shown on screen. Are all equivalent equations? Such transformations help us understand why we change the sign of a number, variable or term when sending it on the other side of the equation. Let's clarify this point through a couple of examples. Example 3. Solve the equations below by explaining each step. A. 2 minus 5x equals x over 3 plus 1. B. 5 over 2x plus 3 is equal to 4 over x for x not equal to 0. Solution 3. A. We have the following as shown on screen. Multiply both sides by 3 to eliminate the fraction. We have the following as shown on screen. Expand and then make operations with like terms. We have the following shown on screen. Subtract 3 from both sides to eliminate numbers from the right side. We have the following as shown on screen. Subtract x from both sides to eliminate variables from the right side. We have the following as shown on screen. Now, write the equation in the form a, x plus b equals 0, we have the following as shown on screen. We have a equals minus 16 and b equals 3. Thus, the value of the variable x is shown in the following on screen. B, we have the following shown on screen. Multiply both sides by 2x to eliminate fractions. We have the following as shown on screen. Expand, simplify, and then make operations with like terms. We have the following as shown on screen. Subtract 8 from both sides to eliminate numbers from the right side. We have the following as shown on screen. We have a equals 6 and b equals minus 3. Thus, the value of the variable x is shown in the following on screen. That is all for lesson 9.1.5, and the end of tutorial 9.1. To continue this chapter, please watch 9.2, Introduction to Word Problems Involving Equations. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.